Standard 3.2, solve linear trig equations whose argument is a multiple of x. So in this standard, we're looking at what happens if we're taking the sine, cosine, tangent, etc. of something like 3 theta or theta over 2, where it's not just plain old theta or plain old x anymore. It's being multiplied by a number or divided by a number. Okay. So let's take a look at our first example here. Sine of 3 theta equals negative root 2 over 2. Now we're going to treat 3 theta, our argument, as a single entity. So we're not going to separate the theta from the 3 just yet. So when we solve right now, we're solving for 3 theta. Because theta is between 0 and 360, 3 theta is going to be between 0 and 360 times 3, or 1080. This is telling us that we have 3 rotations around our circle. So let's take a look at our equation. Again, we're treating everything that's in the box as a single entity. So the sine of something equals negative root 2 over 2. Well, negative root 2 over 2, you should recognize this from your note card as a 45, but because it's negative, it's a 45 in quadrants 3 and 4. And so when we're finding our solutions, we're going to find quadrant 3 and 4 solutions within 3 rotations of our circle. So in our first rotation, we hit the terminal ray, and that angle has a measure of 225 degrees. And if we continue to go around our circle, we then hit the terminal ray in quadrant 4, and that angle measure is 315 degrees. Now that's our first rotation. Let's call this, we'll say it's our first rotation. But we're going around our circle 3 times. So on our second rotation, we continue and we go around our circle. Starting at 0, you go around and you hit 225 like we did, but then we're going to continue around and hit that terminal ray again. So essentially we're finding a coterminal angle. Our question then is, what's coterminal with 225 degrees? So let's add 360 to it, and we get 585 degrees. So in our second rotation, we have 585 degrees. And similarly, on our second rotation, when we hit the quadrant 4 terminal ray, it's coterminal to 315 degrees. And so that's going to be 315 plus 360. That's 675 degrees. Oh, my apologies. These are all solutions for 3 theta, because that's our argument. Okay. Now on our third rotation, we are going to hit those terminal rays again. So let's add another 360 to our current angles. And 3 theta is going to be 945 degrees, or 3 theta will be 675 plus 360, 1035 degrees. All right, well, we have solutions for 3 theta, but our job is to solve for theta. So we're going to divide all of these by 3 for theta. So our first solution, 225 divided by 3, we get 75 degrees. 315 divided by 3, we get 105 degrees. 585 divided by 3, we get 195 degrees. 675 divided by 3, we get 225 degrees. 945 divided by 3 is 315 degrees, and 1035 divided by 3 is 345 degrees. So we have 6 solutions for theta. Notice all of those solutions lie between 0 and 360, which was the original criteria for theta. Let's look at our second example. So the second one is tangent of theta over 2 equals root 3. Again, we're going to treat theta over 2 as a single entity. We're not separating them from each other yet. We actually can't, because that over 2 is trapped inside the parentheses. The tangent is still acting upon it. All right, so If we look at our note card, we know that our reference angle is 60 degrees. And root 3 is positive and tangent is positive in quadrants 1 and 3. Now, because we're dealing with theta over 2, and because theta is between 0 and 360, theta over 2 is between 0 and 180, which is 360 divided by 2. This tells us that all of our solutions lie within half a rotation. So if we rotate through the top half, we don't have solutions in quadrants 3 and 4. The only solution that we have is a quadrant 1 solution, which is 60 degrees. So our only answer for theta over 2 is 60 degrees. Notice it's theta over 2 because that's our argument. If we solve for theta, we're going to multiply both sides by 2, and so theta equals 120 degrees. That's our solution. Suppose for some reason or another you decided you wanted to go with the third quadrant solution. The third quadrant solution would be 240 degrees. But notice that when you multiply that by 2, you get 480 degrees, which exceeds the window for theta there. So that's why we're really restricted to just the top half. We have one solution for theta. That was standard 3.2 linear equations whose argument is a multiple of x.